Good morning, students. We are in chapter 3 today, where we will learn coordinate geometry. Now, we have to understand what is the meaning of coordinate of a point. See, this is a board, and this board consists of infinite number of points. The similarity among all the points are they belong to the same plane or they are coplanar, and at the same time each and every point has got its own identity. For example, let us suppose that in your class there are 40 students. All the 40 students are the students of your class, that is the similarity. But each and every of these 40 students have got his or her own identity. They are having different names. They are having different residential addresses and like that. In the same way, this plane consists of infinite number of points, and each point is different from the other. No two points are exactly identical in all respect. They are different. If I say 2 points are A and B, so definitely the point A has got different identity and point B has got different identity. But what is the similarity between them? They are coplanar, they belong to the same plane. Now, coordinate of a point means exact location or address of a point on a plane. In this plane, points are there, exact location we have to search, exact location we have to find, we have to reach to a particular point, and in order to search that particular point, we need the coordinate of the point. It is the address of the point. Suppose 40 students are there in this class right now, and I want to reach to a particular student's house. How I will reach? I must know what is the residential address of that particular student, where he or she lives, how to go, how to reach to him or her, that all these informations are needed. Similarly, the coordinate of a point helps us to identify a point on the given plane. Example I have given. Remember, in coordinate geometry, the point will always be represented by the capital letter A. Capital letter A means A is a point, P is a point, B is a point, capital letter. And after that, within bracket, I have written 2, 5. This 2, 5 togetherly known as the coordinate of the point A. And in this, the first value 2 is known as the x value, and it is known as the abscissa of the point. The abscissa of point A is 2, and second value is 5. After putting a comma, after 2 we have written 5 over here. 5 means y value. It is known as the ordinate. So abscissa comma ordinate will give us the coordinate. In general, if P is a point, within bracket we will first write x value. Remember, this is mandatory. It is a rule. We cannot do otherwise. First number that we will write, that is our x value, that is our abscissa of the point, comma, then the value that we are writing, that is the y value, which is known as the ordinate. Now, with the help of this graph, I will try to explain the concept of the coordinate. See, our point is A and its coordinate is 2, 5. What to do? we have drawn two mutually perpendicular lines, students. This one is x-axis, this is known as xo x dash, and this is known as the yo y dash, two mutually perpendicular lines. The point of intersection, O, that is known as the origin. On the right side of O, on x-axis, all are positive, on the left side it is negative. Along y-axis, on the above of O, it is positive y, and this is negative y. Now our point is 2, 5. So what 2 is the x value, 5 is the y value. So at 2 we will come, and x is equal to 2 here, and y is equal to 5 at this point. We will start moving and we will stop at the place where we collide. That particular point where both the perpendiculars collide each other, that is denoted as point A, and whose coordinate within the bracket we write as 2, 5. Now, two mutually perpendicular lines, x-axis and y-axis, is in fact, it divides the entire plane into four parts, and each part is known as quadrant. So this is a quadrant. So how many quadrants are there? There are 4 quadrants. Remember, this is known as the first quadrant, this is known as the second quadrant, this is third quadrant, this is fourth quadrant. In first quadrant, remember, x positive, y positive. X and y both are positive on the first quadrant. In the second quadrant, this is the second, this is first. In second quadrant, x negative, y positive. In the third quadrant, x negative, y negative. In the fourth quadrant, x positive, y negative. We have to remember this thing. Now in this way, any point, suppose we are required to find out -3, -2, and let this point be denoted as Q. We have to identify, we have to find out the point Q whose coordinate is -3, -2. So -3, x value, -1, -2, -3, this one. And -2, -1, -2 is the y value. So from here we will start moving on the graph. We will get separate line for each, and wherever we are colliding, that point will be point Q, and its coordinate will be -3, -2. So what we are finding, we are in the third quadrant, and in the third quadrant x is negative, y is also negative. Now something more, what is the coordinate of the origin? Origin's coordinate O is equal to 0, 0. Origin is denoted by O, and its coordinate is 0, 0. Abscissa is 0, ordinate is 0. Suppose I am writing a point R whose coordinate is 5, 0. Abscissa 5, ordinate 0. That means 1, 2, 3, 4, 5. This very point is known as R, whose abscissa 5, ordinate 0. I am writing a point S, and which is 0, -7, 0, abscissa 0, and y is equal to -7. This very point will be your point S, 0, -7. In this way, any point can be plotted on the coordinate axis. Now we will start the very first exercise, students, that is 3.1. Very simple, only 2 questions we have to discuss. Hope you have understood what I mean to say. Now, exercise 3.1 we will do, students. See, exercise 3.1. How will you describe the position of a table lamp on the study table to another person? How will you describe the position of a table lamp on your table to another person? See, the thing is, this is the tabletop. Let this be the tabletop. And here lies a table lamp. Now this is rectangular tabletop. You take any of the edge and treat it as the origin. And this is the table lamp that you are having. Table lamp. Now this will be 90 degree. This is one of the axes. Let it be x-axis. And this edge of the table, this side of the table, smaller side, we can take it as y-axis. There is no hard and fast rule. You can take this one as x-axis and this one as y-axis. This is the frame of reference. Now the table lamp is at point P. From point P, you have to drop two perpendiculars on the longer side and the smaller side. So this is the perpendicular drop on the longer side, and this one is the perpendicular drop to the smaller side. So PM is perpendicular on x-axis and PN is perpendicular on y-axis. Now the coordinate of the point P, coordinate of the point P, that is the table lamp, will be P OM comma PM or ON. OM comma ON. In this way, we can represent the position of a table lamp on the table. How will you describe the position of a table lamp on your study table? We have supposed that the study table is a rectangular one, and this side of the rectangle, that is the length, it is x-axis and this one is y-axis. We can do otherwise also. And P is the position where the table lamp is kept. Now from P we have dropped two perpendiculars, PM and PN. OM is the abscissa, this is the abscissa, x value, and ON is the ordinate. So the coordinate of the point P table lamp on the table is OM comma ON. Now the next one, street plan. See, this question number 2, it is, students, see, in a city there are two perpendicular roads, main roads, north to south, and this is east to west. So we can take this as x-axis, this one is y-axis, they are intersecting at the origin O. A city has two main roads, these are the main roads, which cross each other at the center of the city. These two roads are along north-south direction and east-west. This is north-south direction, this is east-west direction. Now, all the other streets of the city run parallel to these roads and are 200 meters apart. Now, there are roads like this, which are parallel to this, and this is one of the roads. This is one of the roads. All the difference, the distance between the parallel roads are 200 meters apart. There are 5 streets in each direction. Similarly, here also 5, 1, 2, 3, 4, and 5. 5 roads running parallel to north-south direction roads, and 5 roads which are running parallel to east-west direction roads. Now, 1 centimeter is equal to 200 meters. This is 1 centimeter. This one is 1 centimeter. So this is 1, this is 2, this is 3, this is 4, and this is 5. Similarly, this is 1, this is 2, this is 3, this is 4, this is 5. Once again, students, there are 2 main roads. This is called this as east. There are 2 main roads in the city. One running from north to south and the east to west, the second one, intersecting each other at the point of O. Now there are 5 roads which runs parallel to east-west direction, and they are 200 meters apart. And there are 5 roads which runs parallel to north-south directions road, main road, and they are also 200 meters apart. And 200 meter in this graph is denoted as 1 centimeter. Now, draw the model of the city on your notebook. Represent the roads, streets by single lines. Okay. Now, there are many cross streets in your model. Cross streets means 2 streets where they are intersecting. All these are the cross streets. All these dotted points that I am showing, they are the cross streets. These are the cross streets I have shown in the model. These are the cross streets. Cross streets means the point where the 2 streets, one vertical, the second one is the horizontal, intersect each other. Now the question is, a particular cross street is made by 2 streets, one running from north-south direction and another east-west direction. Each cross street referred in the following manner. If second street running north-south, and this one, second street running north-south, the second street running north-south, and 5th street running east-west. 5th street running east-west. They are intersecting at this very point, and its coordinate will be 2, 5. So then we will call this cross street to 5, and using this convention, first question is, how many cross streets can be referred as 4, 3? 4, 3. X value 4, Y value 3. 4 and 3. This is the cross street. 4, X value is 4, and this one is 1, 2, 3. So this is the 4, 3. You can name it as P 4, 3, and the second one is 3, 4. How many cross streets can be referred as 3, 4? 3 and 4. This is the 3, 4. Let it be Q. Its coordinate will be 3, 4. How many points are there whose coordinate is 4, 3? Unique. Only one. That is the point P. How many points are there which are having the coordinates 3, 4? There is only one, and that point is denoted as the cross section, as the cross street of 4th east-west, and that is the 3rd north-south. So I hope you have understood the basic concept of coordinate geometry given in 3.1 with the help of these 2 questions. So students, next we will start 3.2 in the next class.